All right. So the talk was supposed to be about an hour. Let's see if we can get it done in 40 minutes. Do you think that's possible? Yes, it is.
It better be.
Okay. So first I'm going to set the stage. But warning, I'm going to be reasonably frenetic, and it's not just because I got to get out of here. This is my normal state. So set the stage here. Is this dangerous? Oh, it is. Okay. Can you think of a world where it wouldn't be? Container. All right. Is this dangerous? Now, does your answer change if I told you that this was for a load balancer health check? My expectation is that you'd say, for both of these, it depends. For the RM minus RF, you can imagine a world that the alternative might be that you can expand and you have to delete that stuff manually. Oh, and by the way, you have 10,000 and they're nested directories. The point that I want to make here is that all work is contextual. And we're going to come back to this in a little bit. This is a slide about me. That's not really important. The one thing that I do want to get across is that the last time that I felt so excited or critically focused on something was 2009. It's been a long time since then. It's not that I haven't felt excited about something. But I gave this talk in 2009 about continuous deployment with my good friend Paul Hammond. This and a number of things led me to end up doing a master's degree program in human factors and system safety. I'm going to put one slide up here as a plug for a report that I helped put together called the Stella Report. It's at stella.report. It's effectively a year-long project. The result of a project we called Coping with Complexity. It's an industry-academic partnership with IBM, Etsy, and IEX, and the Ohio State University Cognitive Systems Engineering Lab. If there's anything that you take away from this, is please take a look at this. It's long, but I think it's really important. So here's what you're in for here. First, I want to tell you about resilience engineering. It's both a field of study and a community. I want to give you, as best I can, a cognitive systems engineering perspective of continuous deployment, continuous delivery, continuous integration, and a lot of the things that come with that. I want to talk a little bit about what it means to be poised to adapt, poised to deploy, poised to make changes, and then I'm going to end hopefully with some thought-provoking questions. And some philosophical grenades. So resilience engineering is a field, like I said, field of study, largely comes from cognitive systems engineering, and at a really, really, really high level, what you might think of as human factors, which really just started in just post-World War II, all the way up through, about roughly 1979. That's kind of a joke because I'm very specific about roughly 1979 with the accident in the States of 3 Mile Island. Some folks may have heard that. That event in and of itself completely flipped the world of human factors, and a collective there was a collective existential wrestling that took place over the following 10 years, which was effectively things don't work the way we had thought they worked. That's what led to cognitive systems engineering. We'll talk a little bit more about that. Resilience engineering largely grew out of cognitive systems engineering for the most part, although it's interdisciplinary, multidisciplinary. And at this point, there's been about 7 symposia, about 12 years. It's largely made up of practitioners and researchers from these fields, like I said. It's not just cognitive systems and human factors and ergonomics, but some of these others. And they've been working in these domains. And what these domains have as commonalities are that people are continually needing to work in complex scenarios that have some characteristics of uncertainty and ambiguity and high consequences. and when things look like they might not be going well or might not be going as well as we might think, then those consequences can be large and that sort of thing. Now notice I've got down here in green, software engineering. Don't let the size of the font scare you. This is aspirational. The fact is that software engineering is only a very, very recent attention of focus, and the Stellar report and the consortium that we had built has been part of that. So here are the folks that I now hang out with. These are names. Some you may have heard of, some you might not have heard of. My expectations, you'll hear probably a lot more of them. If I'm successful in this, you might go read some of the things that they've written. Huge influences on me. Some of them have been my professors. Certainly some of them are now colleagues. Now, make no mistake, I have come from software. My last gig was Chief Technology Officer at Etsy.com. Before that, I worked at Flickr, and I have come up in software. But at the same time, I have now my foot in research and this field of study, and as a practitioner. As it turns out, these are those 2 feet, the foot in each camp, is quite common. Shauna Perry is a nurse. Dr. Richard Cook is an anesthesiologist. Sidney Decker is a pilot. So is Johan Bergstrom. And so, actually, the only body who doesn't have like a real sort of day job is Dave Woods, and we make sure that he's aware of that. So here's just a random. I went to go look to see what are the types of subjects, what are the titles of papers, of presentations, projects that these groups over the last, like I said, 12 years. So here are some of the titles of the projects. Experiences in Fukushima Daiichi Nuclear Power Plant in Light of Resilience Engineering. Unmanned aircraft systems in international airspace. Resilience as a lever in the debate. Socio-technical networks for power grid resilience, the South Korean case study. Limits on adaptation, modeling resilience and brittleness in hospital emergency departments. And my point in telling you this is not just to reflect really the sort of the diverse attentions that this community has given the research and tried to understand, but also just note to say that these people aren't fucking around, to be really super blunt about it. They're paying attention to very critical, important operations across the globe. And if you want to go read a little bit more about that, then you certainly can. Okay. This next bit is a bit important, and I'd love for you to pay attention. What I want to do is describe how we, cognitive systems engineers, have viewed, largely through the work in the consortium that's now roughly about 2 years, the world that many of you inhabit. And so this model, this sort of landscape, starts with this. Right? And so what we have here sort of depicted, don't worry about this cloud, it's just a sort of a it's not a container. It's a enclosure, thank you. So this is the thing. This is the thing we have the outside world, and this is the service that possibly that you serve to your customers. So what's inside here is your source code, maybe your databases, some way that you deliver this service. Okay, it's the thing, right? For me, for 7 years, this was Etsy.com. Okay, so we could say that this is the system, and we certainly put our focus of attention in here, but we know that that's not correct, and especially for this group. So if we were to sort of expand this and show this actually a little bit more, well, if we pull this back, we see all the stuff we use to make changes in that thing that supposedly delivers business value, hopefully, right? And so what do we see there? We see things that help us deploy. We see things like testing, validation. We've got all sorts of organization, encapsulation tools. We've got monitoring tools, those sorts of things. Now, if we were to say that this is the stuff we use to build the thing that is the business that gets it to customers. And we could say, well, that's maybe the system, but if we stay that right there in that part of this model, we don't see where the real work happens. So what we're going to do here is we're going to draw this sort of line, we call this line of representation. I'll come to in a bit. We can see, what do we see? We see you. We see all of the people who are getting stuff ready to add to the system, changing the system. We see people thinking and building and designing architectures. They're keeping track of what things are what are things below that line, what are they doing, how it's doing it, what's going on with them. Now, and so in this diagram, you'll notice that each one of these people have some sort of mental representation of what that system is. And if you look at it a little bit more closely, you'll see that none of them are the same. So, by the way, that's very characteristic of these roles. Nobody has the same representation. So to summarize, we pull this back a little bit further. What we've sort of covered here is this, your product or service, right? The stuff you build and maintain that service with. And this above the line region, and this is what I'm going to assert, is that this is where the work actually happens. So this is our model of the world, and it includes not just the things that are running there and the kinds of activities that you're performing. It's the cognitive work that you're doing to keep the world functioning. And if we were to elaborate on this and play with this just a little bit more, we end up with this kind of model. Okay? This model has this line of representation going through the middle, and you interact with the world below the line via a set of representations. Your interactions, this is really important, your interactions are never with the things themselves. You don't actually change the system. What you do is you interact with the representation. And that representation is something about what's going on down below. You can think of these green things right here are the screens that you're looking at throughout the day. But the only information that you have about the system comes from these representations. And what's significant about that is that all the activities that you do, all the observing, the inferring, the anticipating, the planning, the reacting, the modifying, has to be done via those representations. So there's a world above the line and a world below the line. And though mostly we talk about the world below the line as if it's very real, as if it's concrete, as if that's the thing, here's the big surprise. You never get to see it. It doesn't really exist. In a real sense, there is no below the line you can actually touch. You never, ever see code run. You see representations that have told you that something that looks like how code might look like if it had run, ran. You never ever see the system actually work. If you were to go into a data center, even Amazon's data center, and look at the servers, you're not going to be able to tell what's happening, right? The only way we can is via these representations, and we build those representations. And so we need, the reason why we have those representations is this is why we build those mental models, right? Those conceptions, those understandings about what's going on. Those are the things that's driving our manipulation of the things below. It's not the world below the line that's doing it. It's our conceptual ability to understand the things that have happened in the past, the things that you're doing now, and why you're doing those things, what matters about what you're doing those things, and why what matters matters. The idea is that once you adopt this perspective and once you step away from the idea that below the line is the thing you're dealing with and understand that you're really working above the line, all sorts of things change. And that's some of the work that we've been doing, both in the consortium and what we've been doing in this new company that I've been building. And we've tried to explore some of those changes. This is what taking a cognitive systems engineering perspective at the world looks like. It looks at work. In other words, these cognitive activities, both individual and collectively in teams, up and down in an organization, are what make the actual business work. And I've been studying this in detail for some time now. And I'm going to assert that it doesn't happen the way we think it does. Now, the most important part of this, and it's fine for me to give this diagram, the most important part of this is that these things change over time. And in fact, this is a dynamic process that's continually ongoing. So this is the unit of analysis that I want you to have in your mind for the rest of the talk. Cool? This is the groundwork. So resilience. There's a view in resilience, and what was great about what Steve said in his introduction is he made a distinction between resilience and robustness. I want to tell you a little bit about how the resilience engineering community perceives resilience, and it is different than robustness. One of the things that's quite clear is that resilience is something that a system does. It is active. It is not a property. It's not what a system has. And that's a bit of a departure from the way we've usually thought about this particular term. I'll read a little bit here. And this is written by Eric Hallnagel. And he says, resilience is an expression of how people, alone or together, cope with everyday situations, large and small, by adjusting their performance to the conditions. An organization's performance is resilient if it can function as required under expected and unexpected conditions alike. And that means changes, disturbances, and opportunities. Dave Woods puts it a little bit more succinctly, and he says that resilience is sustained adaptive capacity. Note this is not sustained adaptation, but is the capacity to adapt. The way that I like to say it, and the way that I've learned from my colleague, Dr. Cook, is say it this way. Resilience is the story of the outage that didn't happen. That's another sort of somewhat pithy way of saying it. So what does this have to do with continuous delivery? So these are words that we use to describe the benefits of continuous delivery. And we've seen for a number of years. This is normally the type of, am I wrong? These are words that are familiar to folks. So now I'm going to show you something here. Right, so small and frequent. Risk is a word we'll use, certainly to possibly reduce risk, and we may shorten lead time, whatever. All right, so take a look at this. You may recognize this piece of code that you may have written this in the past. So here are 6 lines, and there are 79 characters, okay? Here's 1 line, it's 26 characters. These produce the same result. Okay. So the point was so the underlying bit here is that size is a normative. Small is normative. It means that it's contextual, just like the earlier examples. What do we mean by small? The fact is that we know this. We know this so deeply that sometimes it's almost a given that a change is not a change is not a change. Canaries are different than feature flags. Feature flags are different than ramp-ups. Ramp-ups are different than DB schema changes. Network hardware, front end, you're going to design some sort of chaos engineering fault injection, et cetera, et cetera, et cetera. Different changes, forget about the size, carry different types of risk. And in fact, the same change, objectively, the same code, the same application of where that change in the code, in one organization can mean something completely different. Let's see. Raise your hand if you trust NFS to store and keep and have all of your critical data accessible all the time. Raise your hand if you've ever had an issue with NFS mounts and data not being available. Okay, keep your hands up. Has anybody ever run out of file descriptors? Right, so if this happened yesterday and you're looking at something, making a change to that system, messing with that stuff is very different than you've never had a problem with it. There's a big part of risk that's socially constructed. This doesn't mean that it's not real. And it doesn't mean that everybody in your organization, but I'm willing to bet that if we went to your organization and talked to the people who've been around, the veterans, the people who know the ins and outs, the nooks and crannies of your systems, and said, hey, what's the most, flaky? Oh no, flaky's not a good idea. No, a good word. What's the most temperamental part of your system? You know? People have been around and are like, yeah, I could, I don't even have to describe temperamental. I mean, like, yeah, it's this mod Perl thing that we haven't, replaced or whatever. We know that the situation is much more complicated than usually described. We know that deploys get different evaluations based on their perceived risk. A CSS change may have different perceptions of risk than an ORM change. A BGP change may be viewed different from a schema change. In fact, if a database schema change, DBA might actually have a different perception of risk than on a schema change than another engineer looking at the exact same schema change, right? Because these are contextual. Sometimes freedom to deploy is sometimes restricted. Maybe all your investors are coming to the office that day. Maybe it's Cyber Monday. Maybe it's maybe you work at Equifax and you just had a really bad day yesterday. Risk hedging is common. I mentioned canaries and like risk hedging is actually one of the most valuable techniques and approaches that we use to sort of reduce this risk, even if it's not universally and objectively comprehensively known. And conventions are everywhere. Like, we use Postgres, or we use Mongo. Well, around here we use that disruptor. Oh, we can't wait. It's good. It's the greatest. In other words, all work is contextual. And this context is constructed up here. It's not constructed down here. We construct this risk. There's actually, sorry if there are any accountants in the room, the concept comes from finance. And there's not, no matter what actuaries want you to believe, it's actually not quantifiable. If you push it from a sociological standpoint, it's not. That's okay. So what does it mean to be poised to deploy or poised to adapt? So there's a handful of things, and this is from Richard Cook's talk, if you haven't seen it, and this was his 2016 talk. What does it mean? It means knowing what the platform is supposed to do. It means knowing how the platform works. It means knowing what the platform's behavior means. It means being able to devise a change that addresses that 1, 2, and 3. It means being able to predict the effects of that change, being able to force the platform to change in that way, and being prepared to deal with the consequences, right? I'll ask this question that I ask a lot of audiences. Raise your hand. If I were to give you an afternoon, raise your hand if you feel confident you might be able to figure out a way to take down your business's service with one character. Raise your hand. What if I give you 2 days? Really? Yes, of course. Elizabeth's like, of course. This is quite common. So there's a huge amount of uncertainty. This matches, and it looks a lot more like air traffic control than I think you all realize. By the way, you are so much calmer to present to than a room full of air traffic controllers. I have some experience with this. By the way, air traffic controllers and other people from this safety, because I've been hanging out with all these sort of other safety critical folks, they have no idea how pessimistic software engineers are about software. Right? I was told once that distance lends enchantment. The further you are away, the more magical it becomes. And I think the opposite is that, and we all know this, familiarity breeds contempt. So if we think that, stole this from Noah Sussman, if we believe that there is no such thing as bug-free code, if we believe that complete, objective, comprehensive testing is impossible, right? The fact of the matter is, how does anything work, right? I've just told you a whole bunch of things but actually, surprisingly, we make things work. And that all happens above the line. So we have to see that these terms like risk and small and frequent and all of those sorts of things are normative terms that are context dependent with our teams, right? And once we take this perspective and what we've been studying in software teams, and we're now in the second cycle of the consortium, we want to ask and talk with these people who like you. And we ask questions like this: how does our software work really? No, not how it's described on the wiki and on the diagrams, because we know that those aren't comprehensively accurate, right? We know there are nooks and crannies, and we know that you actively avoid them, even if you don't notice that you avoid them. Raise your hand if you were to shell into a server for the first time. You have a couple of go-to commands you just quickly run, right? And so folks, right? Somebody yell one out. PS, LS, top. Right. Oh, by the way, I just have to ask, is anybody here like a compulsive clearer? Yeah, happens, right? But how does our software break, actually? This is actually a really great question versus how we thought it would break when we put in all those fail-safes and safeguards. This is the greatest thing about incidents. We'll get to that in a little bit. And what do we do to keep it all working? And the answer is, it depends. It's contextual. So, how do we discover from a research perspective, because I know you're all really want to nerd this out, how do you discover about what happens above the line? Magic. No, it's not magic. What we can learn from the study of other high tempo, high consequence domains is that we can study incidents. And by the way, when I say incidents, don't hold me to some sort of ITIL definition here. What I mean is outages, degradations, breaches, accidents, near misses, glitches, all those things that are surprising. So, but what makes incidents interesting and valuable outside of the standard reason, which is revenue and reputation effects on a business, that sort of thing, right? Well, a couple things, not inclusively, but incidents we know that incidents can be hugely influential, right? They can sometimes significantly affect how we design new architecture and software, right? You can't say that if we're going to re-architect this or we're going to do some legacy migration. You can't say, but we're not really taking into account all of the times that the older service, we're going to completely disregard how many times that we've had issues with that, right? It shapes the design of new components, subsystems, and architectures. We see this in real life. Another way of saying this is that incidents of yesterday inform the architectures of tomorrow. Absolutely, I think that this is the case. And that incidents below the line drive changes above the line. What does that mean? It means, guess what? If you're doing re-architectures, if you're doing mass migrations, if you're going through some sort of digital transformation, it means it can have not an insignificant effect on staffing, budgets, planning, and roadmaps. This costs real money. The influence of incidents that it has in an organization can move well beyond the last minute of the postmortem debriefing. Incidents can also be motivators for policy. They tend to give birth to new forms of regulations, policies, norms, compliance requirements, the explosion of documentation, auditing constraints, etc. In other words, another way of saying is incidents of yesterday inform the rules of tomorrow. They, therefore, can influence staffing, budgets, planning, roadmaps, blah, blah, blah. There's some examples here. Regulation SCI. Oh my God, there's no way I'm going to get through these. And PCI DSS. Incidents tend to focus our attention on what matters, right? They tend to wash away stuff that doesn't really matter because you're under pressure and you don't mess around with things that you don't think are going to be fruitful. Incidents help us gauge the delta between how the system works and how we think the system works, and that's almost always greater than we imagine. So, when we look deeply at incidents, these are the types of questions that we hear, right? By the way, it would be, except for this last one, right? Raise your hand if you think that these are the types of questions you would see if I went into your outage war room channel, or you're listening on your bridge. Right. So guess what? All of these, except for the last one, are exactly what the pilots told Earl Weiner when they were testing new automation in the cockpits of 747s at NASA Ames in the 80s. So, I'm going to skip forward. All right, let's talk through this example. Here's a diagram of an incident. What does this data tell me? Well, it tells me that you had an incident and that somebody believes within some criteria that it took 54 minutes. Outside of that, I'm not sure it tells us anything else, but imagine we have, let's say someone believes we detected the incident at about 12 minutes into it. What do I now know about the incident? What do I know about the team that worked on it? The group that worked on it? I don't know anything about it. But that's okay, it doesn't matter, we'll get some more data. We literally have 4 times the amount of data than we started with, right? This definitely will tell us no, actually it doesn't tell us anything. What if we have 3? What if we have 4? What if I were to highlight and mark the time to detect and time to resolve of these incidents, right? And I lay it out on a timeline to when they actually occurred. And you know it's real when I can draw some lines and plot it on a chart, right? What does this tell us about the incidents? What does this tell us about how people solved the incident? What does this tell us about what they struggled with? It doesn't tell me anything. Now, if this doesn't tell me anything, what would calculating the statistical mean of these do? Would that increase what I would know? Remember, resilience is an expression of how people alone or together cope with everyday situations, large and small, by adjusting the performance to the conditions. Now, does that graph help us answer any of these questions? Incidents provide calibration about how decisions are focused, how attention flows, how work is coordinated, how escalation manifests, the weight of time pressure, the effects of uncertainty, sometimes ambiguity, and what consequences are consequential. Sometimes the thing that you're so sure is going to fix the thing makes it worse. Oh, you're the mom. So what can we learn about this from these? There's another way. I can state this a different way. And I'll speak from a member of the resilience engineering community. While there's value on the items on the right, we value the items on the left more. My good friend John Willis noticed earlier when I showed him this slide that all the ones on the right are numerical, and all the ones on the left are not numerical. And I think that that's critically important. This is valid data: frequency of incidents, severity, customer impact, number of deploys. This is valid data. Just because it's valid data doesn't mean that it gives you insight into everything or what you think it might. So, here's some things to leave you with. I'm going to assert that we cannot comprehensively understand how our systems behave. We continually build and revise our understandings based on relatively sparse signals that our technology sends us. One of those signals is incidents. Incidents are really just our systems telling us where our understanding was not as spot on as it actually is. I'd say that applying CD approaches, techniques, is an implicit acknowledgement of this sparse and fleeting understanding, right? Otherwise, large batch sizes and rarely changing wouldn't matter. And that CD represents coping strategies, very evolved, more evolved than I think you all know. Coping strategies for this state of affairs. When I met Dave Woods and convinced him to speak at Velocity, this is a man who, to this day, will say that 3 Mile Island kickstarted his career. This is someone who has been in nuclear power plants, in surgical trauma units, in military, in intelligence. He sat on the accident investigation boards of many space shuttles, just 2, and countless accidents. including Air France 447 for those who read Wikipedia. And he told me when I brought him to our community, I said, Dave, I think there's something here. And by the way, I've stolen so much from you and your research, and I don't know if I'm doing it right. And I took him to Velocity, he gave a talk, and he said to me later, he said, I had no idea that this was a thing. And I think that actually it's not only that this is a thing, but I think that you're the future. I think that the approaches you developed in your community, whether you recognize it or not, should be used in these other domains, at least at a generalized approach. And he's now been spending a lot of time talking to people in aviation and all these other, saying that the approaches that you all heard about today and you all read about, many of the things that Elizabeth talked about started at the very beginning of the day, he's talking to those people in governments and airlines and power companies. Lastly, I'm going to say that understanding activities above the line are basically unexplored and ignored in our industry, and this needs to change. That's my hope. My hope is that I'm going to throw so much of conventional wisdom out the window at you that you'll say either this guy's full of shit or maybe there's something there and I could maybe go read some more about it. I do believe that the increasing significance of our systems, the increasing potential for economic, political, and human damage when they don't work properly, the proliferation of dependencies and associated uncertainty make me very worried. And I think that if you were to look at your own systems and its problems, I think you will agree we have to do more than just acknowledge this. We have to embrace it. This is happening. This conversation is happening. I want software engineering to be a part of what this looks like. And I think that the same type of paradigm shift that happened with 3 Mile Island, we can do without an accident kicking it off. So thank you for listening. Thanks for letting me go early and extended time, that sort of thing. Thanks.
Thank you, John. That was awesome. So through the power of Ebru and cheating, we have time for questions. Please don't think too hard about where that time came from. So who'd like to ask the first question? Here we go.
This is a bit of a weird one. Do you ever find it really weird that we can create entirely all of this with logic and yet somehow we still don't understand what we just built?
Yes. I mean, to be honest, it's as my good friend Daniel Schaumburg said, this is as close to being wizards as we will ever get. And I could not agree more. Yes. Is it weird? Yes. Paradoxical? Yes.
Your ignorance is your shield. Okay. Next question. Really? Oh, one of the friends. Okay. John.
How do you remain optimistic in such a thing?
It's a great question. And this is one of the things that I didn't really talk about, but a huge core tenet of resilience engineering is that adaptive capacity comes from people. People, it's easy to be pessimistic, but it's also, we have to acknowledge that what's said sometimes is that Murphy's Law is wrong, right? The general view of Murphy's Law is that anything that could go wrong does. But we know that that's factually incorrect because what could go wrong almost never does. And we never look at that. We look at, because those don't stick out. And the idea that people make adjustments to their tools, their environment, all that's contextually, they make good decisions almost all the time. And sometimes we make crazily good decisions amidst ridiculous amounts of astronomical amounts of uncertainty, where getting it wrong could be huge. And yet we work it out. And we have more, uptime is counted in 5 nines? Come on. And so I feel very optimistic because I also feel very optimistic in software because we do not have, not even close to the gates and ridiculous hoops of regulation that these other, and if we stay ahead of it, we can keep it that way.
That was going to be my own point. Why this is
Use the microphone, John.
why this is so important. I think John in his DevOps Enterprise Summit presentation did a great, like that aviation, or maritime, all those things have this, what are the consequences of us getting it wrong? And in IT, we've had this free kind of get out of jail free card of not really having to think about that when we go in and we touch a computer. But as we all know, that's changing rapidly fast. It's
It's
the
been
consequences of things us getting it wrong in most of the places we're starting to interact with might cause death, can certainly cause commerce disruption worldwide. So this kind of thinking stems from those other disciplines. Sorry, John.
Yeah.
And so that's why I think what he's saying is so important. We need to get our head around this, like aviation did, like maritime, the way doctors think about when they're, Richard Cook and anesthesiology.
We will be better than all those domains.
Right, because
And
we're
they scare
doing it
the shit out of
before.
everybody.
Yeah.
But we will be better than those because we won't be hampered. We do not have to fight against a history of accidents, putting things. Pilots can be fired for entering a cockpit with a styrofoam cup of coffee that doesn't have a cover. Compliance running amok. You think SOX and PCI is bad? Yeah, so I think we can be way better. Anyway.
Maybe a little bit philosophical. What's your take on anti-fragility in software engineering?
I don't like the concept. I don't
Fair
like the
enough.
concept. There are many reasons that would take too long, but I do not believe that it's supported empirically. I do believe that it has already risked becoming what's known as a folk model, which means people could just say, "Oh, you had an outage. You must be fragile." I don't like Taleb's condescension to the rest of the domains, and multiple domains have been studying this, and so I'm not a fan.
Thank you.
Diplomatically.
Okay, time for 2 more questions. One here.
So the models above the line, the mental models, do you see value in trying to join these mental models above the line?
Oh yeah, and that's this talk that I gave in November at the DevOps Enterprise Summit talks in quite great detail about that. And one of the points is effectively that we have an opportunity in post-incident reviews to recalibrate. Now that means not different. That's different than alignment. But yeah, when you have an opportunity, especially you're skilled, there are techniques and methods and approaches you can do that you can use. It takes a lot of work, but a huge part of those, it's one thing to have it on a diagram, but a huge part of those are tacit. You may have a picture in your head of how the system works and like that has like a quality and sort of a shape and behavior to it, but you may not have ever said that out loud, or might not even be able to have the words for it. And but that doesn't mean that it's not real to you. And so what post-incident review is, going beyond what I would pejoratively call template-driven postmortems, going deeper, a deeper analysis would allow people, set up the conditions where people can compare and contrast. Oh, this is how I thought it worked. And in fact, actually, some of the from the Stellar report, that was a huge. That was common across all. We looked at an outage at all 3 organizations, and all of them had multiple times when people said, "Oh, I didn't know the system worked that way," and then actually in a couple of cases, in some scenarios, the next thing that those people said is, "Wait, Now I don't understand it, how it works at all. It can be so. So yes, I mean, that's it. That's the gold.